Good day, students. For today's agenda, we will be discussing the second part of our two-part lecture for Chapter 3, which is Entropy and Free Energy. So, yung agenda natin for the second part of our discussion includes Gibbs free energy, your standard free energy change, and lastly, your free energy and chemical equilibrium. So, yung tatlong topic na yan yung magiging discussion natin for this particular video. Okay? So, one moment lang, no? Scroll down natin pababa doon sa slide. Okay. So, before we start, let us go back to what we've discussed from our previous lesson, no? From our previous lesson, inintroduce natin si entropy, no? And nung inintroduce natin din si entropy, diniscuss din natin yung dalawang natitira for our three laws of thermodynamics. So, sabi natin for entropy, it is just disorder. Or ito yung energy form na nagsasabi kung spontaneous or non-spontaneous yung isang reaction. So, quick review tayo. Pag sinabi nating spontaneous, meaning, anong meron pag spontaneous? Dapat nangyayari yung isang reaction. So, pag sinabi mong spontaneous yung reaction, nangyayari siya. Okay? Another term na ginamit natin is yung term na non-spontaneous. So, pag sinabi natin non-spontaneous, ang definition lang nun is hindi nangyayari yung reaction. And from there nga, diniscuss natin yung second law of thermodynamics, which is, sabi sa second law of thermodynamics, in order for a reaction to be spontaneous, dapat yung value ng delta S universe is positive. Okay? Or, katulad ng nakalagay dito, it should be greater than 0. So, technically, dapat daw the delta S universe should be greater than 0 para na masabi natin na positive yung particular reaction or spontaneous yung entropy niya. Ngayon, let me emphasize then na for this particular term na ginamit natin, which is the delta S universe, ito yung parang tinitignan natin, no? Sa second law of thermodynamics. So, yung delta S universe yung tinitignan natin. Hindi natin tinitignan sa system, hindi natin tinitignan sa surroundings. Instead, we're looking at the universe. So, yung system plus surroundings yun. And from our previous lesson nga, magkaiba yung way natin ng pag-calculate for the delta S system and magkaiba rin yung way natin ng pag-calculate for the delta S surroundings. So, imagine that, no? Sobrang hirap ng pag-calculate for the delta S universe kasi we're considering both the delta S of the system and the delta S of the surroundings. So, dalawang value yung hinahanap mo and from there, makukuha mo pa lang yung value na delta S universe. Okay? So, with this issue, no, dahil nga medyo mahirap yung pagkuha ng delta S universe, kasi imagine mo na lang, para malaman mo kung spontaneous yung isang reaction, kailangan mo mag-solve ng two separate na values. Yung isa for the delta S system and yung isa for the delta S surroundings. So, talaga namang medyo pahirapan. So, dahil nga pahirapan yung pag-calculate for the delta S universe, nag-isip yung mga scientists, no, ng way to simplify this issue. So, in that case, nag-develop sila ng another energy form. Yun na yung tinatawag nating Gibbs free energy. So, dito papasok sa picture si Gibbs free energy. Okay? So, ulitin lang natin, no? Emphasize natin. Kaya nag-introduce ng new term yung mga scientists natin. Kasi sabi nila, mahirap mag-calculate ng delta S universe. Kasi we're looking at both the delta S system and the delta S of the surroundings. Which is, kung matatandaan nyo from our previous lesson, specifically on internal energy, yung focus kasi natin for the calculation of the internal energy and also enthalpy, focus lang siya sa system. So, yun yung gusto nating gawin or yun yung gustong gawin ng mga scientists before. Gusto nila bumalik yung focus natin sa system lang. Yung hindi natin kino-consider yung hindi natin kino-consider yung si surroundings and of course si universe mismo. Okay? With that said, let's look at the equation here, no? Kung matatandaan nyo, ito yung equation natin para makuha natin yung delta S universe, which is simply the sum of the delta S of the system plus the delta S of the surroundings. Tapos yung condition natin dito, it should be greater than 0. Bakit daw dapat greater than 0? Kasi nga sabi natin, in order for the delta S universe to be spontaneous, dapat positive yung value niya. Okay? Ngayon, kung matatandaan nyo, meron tayong formula for the delta S surrounding, which is given as negative delta H of the system over D. So, etong part ng itong na-derive natin from our previous lesson, we can actually input it, no? Pwede natin siyang i-input dito sa ating equation. So, ito, i-input mo lang dito. So, from there, makakarating na tayo dito sa part ng ating equation. Ngayon, anong next nating gagawin dito? Pwede nating i-remove yung denominator. So, how can we remove the denominator here? So, we just have to multiply both sides by temperature. So, from there, multiply natin ng temperature yung buong equation. So, mamultiply ito dito, tapos ito, makakancel niya yung sa baba, tapos mamumultiply yun dito sa term na to. So, from there, nagkaroon tayo ng T delta S universe is equal to negative H system plus T delta S system. So, ngayon, ano naman yung pwede natin gawin dito? Okay? So, something na pwede natin gawin dito is pwede nating i-multiply yung buong equation into by negative 1. So, imumultiply natin yung buong equation ngayon ng negative 1. So, yun yung ginawa nila. So, minultiply nila tong equation ulit, both sides of the equation by negative 1. So, mag-change lang yung sign ng mismong equation. So, for this, naging negative siya. This one, naging positive. This one, naging negative. And from there, students, dahil nag-multiply tayo ng negative 1 sa buong equation natin, no? Sa mathematics kasi, pag nag-multiply ka ng negative sign sa isang inequality, ang mangyayari is magkakaroon ng reverse or kabaliktaran yung relationship. So, kanina, itong equation na to, dapat daw should be greater than 0. So, dahil nga nag-multiply ka ng negative 1 sa isang equation, ang mangyayari dito is mababaliktad yung relationship niya. So, instead of this equation should be greater than 0 daw dapat, ang mangyayari is it should be less than 0. Okay? So, anong implication nitong equation na to? So, ito na yung na-derive ng mga scientists, no? Okay? So, anong implication or ano yung sinasabi ng equation na to? No? Bakit tayo naka-arrive dito? So, for you to determine the spontaneity of the reactions, all you have to do now is look at the delta H of the system and at the same time, the entropy of the system. So, kung mapapansin nyo kasi, for this particular equation, students, ano na lang hinahanap natin? We're just looking for the enthalpy of the system and we're looking at the entropy of the system na lang. So, natanggal na yung factor na we're looking at the surroundings. Which is yun nga yung gusto ng mga scientists. Bumalik yung focus natin sa system lang. So, ngayon, at the same time, meron din tayo dito nitong term na to, no? Which is si negative T delta S universe. Okay, so anong meron dito? Okay, so later on, ano natin to mas papakita natin kung sino tong term na to or papangalanan natin yan, bibigyan natin siya ng name. But something na pwede nyong inote pa from this particular equation na na-derive ng mga scientists natin is that, yes, we're looking at the system na lang, no? Wala na yung surroundings unlike the second law of thermodynamics. But students, something that you need to note is that for this particular equation, dapat daw yung value natin should be less than 0. So, in order for us daw to tell if a particular reaction is spontaneous or non-spontaneous, dapat daw, ang value daw natin makukuha should be a negative value. So, kabaliktaran ng entropy. Kasi from entropy, students, 'di ba? Para masabi nating spontaneous yung isang process, dapat positive si delta S universe. Ngayon, for this particular equation na dinerive ng mga scientists, ang naging condition na natin is para daw masabi nating spontaneous yung isang process, dapat daw less than 0 siya or negative yung value niya. Okay? So ngayon naman, i-shift natin ulit yung focus natin dito sa negative T delta S universe. So for us to provide a name to this term, we just have to introduce a new energy form. Okay? So yun nga yung ginawa ng mga scientists, 'di ba? Naghanap sila ng way para mas mapadali yung pagka-calculate natin or pagde-determine natin if a particular reaction is spontaneous or non-spontaneous. At yung ginawa nga nila is nag-introduce sila ng new energy form at yun na yung tinatawag nating Gibbs free energy. So itong part ng equation na to, no? Itong part ng equation na to, itong binabox ko, yan actually si Gibbs free energy. So pupunta tayo sa baba. Okay? So technically student, no? Yung term na to, ginawa na natin to as Gibbs free energy. And Gibbs free energy is represented by capital letter G. So si capital letter G, it represents the new energy form that was introduced by the scientists, which is known as your Gibbs free energy. Okay? So yan nga, basahin lang natin, no? Another thermodynamic function that expresses the spontaneity of a reaction more directly is called the Gibbs free energy. So, emphasize natin yung word na more directly kasi for calculating the spontaneity of a particular reaction using the Gibbs free energy, we're only looking directly at the system anymore. We're looking at the system na lang, no? We're not considering surroundings. Okay, so pasensya na dun, no? But anyways, ito yung naging formula natin, which is delta G is equal to delta H minus T delta S. Okay? So, technically, ang ginawa lang, paano nila nakuha to, no? So, you might be wondering, ang ginawa lang nila, of course, dinerivative nila to. So, nag-derivative sila. And from there, ito yung final formula natin, which is delta G is equal to delta H minus T delta S. Something siguro na ituturo ko sa inyo, no? A quick hack or cheat na pwede kong ituro sa inyo para matandaan nyo yung formula for the Gibbs free energy is you can actually call this formula as your agatas, no? So, parang yung mga delta dito or yung mga triangle dito, you consider them as A. So, parang A, G, A, H, T, A, S. So, pag nag-exam ka, tapos pinapanap yung free energy, you could just simply say agatas. So, that is delta G is equal to delta H minus T delta S. Pero syempre, dapat tatandaan mo yung minus dito na operation, no? Kasi kahit nag-agatas ka, kung positive naman yun or plus sign yan, mali pa rin yung equation, no? So, dapat tatandaan mo pa rin yung operation na ginamit for the formula. Ulitin lang natin, So, instead of calling it as negative T delta S universe, we can now call it as your Gibbs free energy or letter G lang. Okay? So, instead of using the delta S universe, we'll now simply use delta G as a substitute. Okay. So, yun yung ginawa ng mga scientists, no? Sabi nila, okay, naka-introduce naman na tayo ng bagong energy form, which is si free energy. Ito na yung gamitin natin as a substitute for the delta S of the universe para masabi natin if a particular reaction is spontaneous or non-spontaneous. Kasi in this case, we do not have to worry about the universe anymore. Specifically, wala na tayong pake sa surroundings, no? We're only looking at the system ulit. Katulad ng ginagawa natin for the internal energy. Okay? So, another thing ulit na gusto kong ipaalala ulit sa inyo, no? Saan nanggaling yung negative sign, no? So, saan manggagaling yung negative sign dito para masabi natin na spontaneous yung process? Okay, so nangyari yung negative sign, it's because nagmultiply tayo ng negative 1 for this particular equation. So, sabi nga natin, pag nagmultiply tayo ng negative sign sa isang inequality, babaliktad yung relationship. So, instead na this particular equation should be greater than 0, naging less than 0 na siya. So, in order for us to say na spontaneous yung isang process or reaction under the free energy, dapat yung value daw dapat natin ay negative para masabi nating spontaneous yung process. Okay, ganun lang kadali. Okay. So, ito, tignan natin to. So, sabi dito, pag delta G is less than 0, the reaction is spontaneous, ha? So, dapat negative yung sign na to. For this particular part naman, sabi delta G is greater than 0, then technically that is a non-spontaneous process. Okay? And of course, if delta G is equal to 0, it is at equilibrium. Okay? Things that you need to remember. Okay? For free energy, dapat negative. Okay? Hindi siya dapat positive. So, kanino yung positive na condition para masabi nating spontaneous? Para yun kay delta S universe, which is the second law of thermodynamics. But for Gibbs free energy, negative yung condition natin para masabi nating spontaneous yung isang process or reaction. Okay? Moving forward, punta tayo dito. Okay? So, standard free energy change. Okay, something very familiar na rin sa inyo. Nagawa na natin to ng 2 beses, no? Nagawa na natin to for enthalpy, 'di ba? Yung may not. And then for entropy. Okay. So ganun din kay Gibbs free energy, no? Meron din siyang sariling standard free energy change. So technically, meron din siya nung same formula na ginawa natin or ginamit natin for both enthalpy and entropy. So sa mga estudyante ko, nagawa natin yan sa enthalpy. Tapos from the part 1 of this particular lecture for chapter 3, ginawa natin yon for entropy. Okay, so very easy na lang dito yung formula, no? Same lang din naman yan. So the delta G of the reaction is equal to the summation of the product of the moles of the products multiplied by their standard Gibbs free energy of the products subtracted by the summation of the moles of the reactants multiplied by their standard free energy of the reactants. Okay, so ganun lang naman, very easy lang. Okay, so ngayon, let's try to answer, no? Calculate daw natin to. So, again, sabi dito, calculate the standard free energy change for the following reaction at 25 degrees Celsius. Okay, so gagamitin lang natin yung formula natin sa taas. And in order for us to determine kung ano yung mga value ng standard free energy change nila, we just have to look at the thermodynamic data na lang ulit. Okay, so from our previous nagamit na natin to, diba? This is for enthalpy, this is for entropy. So for this particular lecture, yung free energy na yung gagamitin natin, no? Or the standard gives free energy, no? Ito na yung gagamitin natin, which is the second column. Okay? So hanapin lang natin. So, hanapin natin yung free energy or standard free energy nila. So, start tayo sa CO2. Sa product muna tayo mag-start. Okay. So, hanapin natin isa-isa. So, G F of CO2. So, dito ipapakita ko muna kung paano gamitin yung table, ha. Pero sa mga succeeding na na mga examples, kayo nang bahalang tumingin sa table. Okay? Para masubukan nyo rin. Tapos to? O2. And then yung isa ay methane. Okay? So, hanapin natin lahat ng values na yan sa table. Okay? So, for CO2, gas yun. Hanapin natin. CO2 gas is negative 394.4. Sulat natin. Negative 394.4. Anong unit na to? So, check lang natin yung unit. Kilojoules per mole daw. Okay, so that is kilojoules per mole. Okay, next, hanapin natin si H2O, NO2. Ano yung H2O natin? Liquid. So, hanapin natin si H2O liquid. So, H2O liquid, ito siya. Negative 237.2. So, negative 237.2 kilojoules per mole. And then, let's look for oxygen gas. So, for oxygen gas, titingnan lang natin siya sa table ulit. Naka-alphabetically arranged naman na to, no? Oxygen gas. Ayun, O2. 0. Okay, so for oxygen gas, that's 0 kilojoules per moles. Si methane, okay, syempre, ano ko na to, no? Medyo master ko na rin, kahit pa paano yung table. Hindi natin siya makikita alphabetically arranged dito. Nasa organic compound siya. Okay, so methane is an organic compound or an organic substance. Sorry, nabulol ako doon. So, hanapin mo lang dito si methane. Okay, so methane is CH4. Siya ay negative 50.8. So, ganun lang. Negative 50.8 kilojoule per mole. Okay, so from there, we can use the formula for calculating the delta or the standard gives free energy of the reaction. So, product minus reactant daw, no? I'll start tayo sa product. So, CO2, ilang moles? 1 mole lang. Multiplied by, negative 394.4 kilojoules per mole. Very, okay. So, from there, plus, punta tayo sa H2O, ilang moles? 2 moles. Okay, so 2 moles times yung value niya, negative 237.2 kilojoules per moles. Okay, from there, close na natin using a bracket. Subtracted by, dun tayo sa reactant part, no? So, unahin natin si methane. Unahin natin si methane. So, for methane, that will be simply 1 mole times, value ng methane, negative 50.8. Ngayon, hindi na natin isasama si oxygen. So, you might be wondering, bakit di na natin isasama si oxygen? The reason why di na natin isasama si oxygen, it's because, in the first place, 0 naman yung standard free energy niya. So, dahil standard yung free energy niya, wag na natin siyang isama. Kasi magzi-zero lang din naman yung term na yun. So, technically, hindi na natin isasama si oxygen. Okay, so hanggang kay methane na lang. Para hindi na tayo maraming sinusulat. Okay, so from there, plug in nyo lang sa calculator nyo. Okay, so you can pause the video para you can calculate it, no? So from here, ang sagot natin ay negative 818 kilojoules. Okay, so yung unit natin is kilojoules. So pwede nating i-cancel kasi yung mole sa baba na unit. Okay, so anong implication ng na-solve natin na value? So, itong particular chemical reaction na to, no? This process is spontaneous. So, paano natin nasabi na spontaneous yung process? Nasabi natin na spontaneous yung process kasi negative yung sign nung value for the delta G of the reaction or the standard delta G of the reaction. So, spontaneous. Okay? So, bakit siya ulit spontaneous? Kasi negative yung sign natin. Okay? So, from there, try nyo gawin tong second part. Okay? Same lang yan, no? Same lang din ng process na yun. So, pag sinabi nating STP, no? That is standard temperature and pressure. So, technically, this is at 1 atmosphere pa rin and at 25 degrees Celsius. So, same thermodynamic data pa rin yung gagamitin nyo. Okay? So, in this particular example, students, ulitin ko, kayo na lang gagawa niyan para may practice kayo. Okay? Sundan nyo lang yung ginawa ko sa taas. No? Okay? So, titignan mo lang yung number of moles nila, tapos i-multiply mo sila sa value na makukuha mo dito sa thermodynamic data, pero dapat product minus reactant. Okay? So, ilalagay ko na lang yung sagot dito. Okay? So, yung nakuha nating sagot dito ay for the delta G of the reaction of this particular example, ang sagot natin ay positive 1,139.2 kilojoules. Okay. So, anong implication netong answer na to? So, because of this answer or this value being a positive value, then this particular chemical reaction is non-spontaneous. Okay? Bakit siya non-spontaneous? Because positive yung nakalculate nating value. And based on what we have established earlier, sabi natin, in order for a particular chemical reaction or a process to be called spontaneous under free energy, dapat negative yung value niya. So, itong sagot na to, no, kindly calculated na lang, no? Binigay ko na yung sagot, kayo nang gagawa nun para meron kayong practice. Hindi lahat spoon feeding. Okay? So, with that said, let's move forward na to our lecture. Okay? So, itong susunod nating i-discuss, these are just supplementary discussion for our free energy change, no? So, dito, aalamin natin yung mga factors that are affecting our delta G depending dun sa sign nung ating enthalpy and nung ating entropy. Okay? So, ngayon, titingnan natin tong table dito. Okay? So, one moment lang. Okay, going back, no? As I've said, there are several factors that will result to the spontaneity of the reaction depending on the sign of your enthalpy and your entropy. So, tingnan natin, no? Okay, label natin tong apat na condition na to. So, let's say this is A, this is B, this is C, and this is D. Okay? So, start muna tayo for A. Hatiin lang natin. So, ano yung formula natin na na-derive for free energy? Yung agatas, no? Delta G is equal to delta H minus T delta S. So, ganun din sa kabila. Sulat din natin yung agatas. Okay. So, from there, students, no? Tignan natin yung first condition or first factor na mag-aapekto sa spontaneity ng process. So, paano daw students, pili tayo ng ibang kulay, paano daw students kung positive daw si delta H at positive daw din si entropy? Ano daw yung hahanapin nating temperature para maging negative yung value nitong ating free energy? So, remember, ang goal natin is dapat mag-negative yung value natin for free energy kasi yun yung condition natin for spontaneity. So, pag positive to, tapos positive din to, tapos subtraction yung operation natin, ine-expect natin dapat na yung temperature is at high temp. Okay? So, bakit natin nasabing high temp? So, sabi kasi natin dito positive to. Itong delta H. So, kung positive din to, tas i-multiply mo si temperature sa kanya, dapat itong temperature nito ay sobrang laki para ma-overpower ng value nito, ito. And pag mas malaki tong value natin dito sa right kesa sa left, automatically magne-negative yung sign ni delta G. Okay? So, pag positive si delta H and delta S, dapat high yung temperature. O, yan din yung sinabi dito kung babasahin nyo rin. Okay. Moving forward tayo, ha. Punta tayo dito sa condition letter B. So, ito si B. Ito si A. So, for condition B, positive daw si delta H. Tapos, negative daw si delta S. So, ano naman mangyayari dito? Okay. So, in this case, no, kung titignan natin to, ano naman yung dapat condition for temperature para masabi natin na or para maggawa natin ng paraan kung saan magiging negative si delta G. Okay, so kung mapapansin nyo to, positive tong sign daw dapat ni enthalpy. Pag negative to students, no? Tatandaan nyo, negative times negative, ano? Negative times negative will be positive. So dahil magiging positive tong part ng equation na to, regardless kung ano yung temperature, ibig sabihin lang yan, at any temperature, hindi magiging spontaneous si delta G. So si delta G ay always positive, no temp. Okay. So bakit no temp? Kasi as you can see, student, negative daw yung condition for entropy. So negative times negative kasi positive pa rin. So positive to, mag-a-add lang yun, o di positive din si delta G. So regardless kung ano yung temperature nung example natin, whether high temperature, low temperature, mid temperature, whatsoever, walang temperature ang makakagawa ng paraan para mag-negative si delta G kasi nga yung condition natin for delta S is negative. Okay? So, pakitandaan lang dyan. Kung titignan mo rin naman to, sabi dito, delta G is always positive, reaction is spontaneous in the reverse direction at all temperatures. So, reverse, pabaliktad kasi. No? So, yun yung sa letter B. Okay? Punta tayo dito sa pangatloan pa ang apat or si letter C and letter D. So, this is A, B, C, and D. Okay? So, punta naman tayo ngayon kay C and D. Okay. Sulat natin ulit yung agitas. Delta G is equal to delta H minus T delta S. Okay, ganun din sa kabila. Delta G is equal to delta H minus T delta S. Okay, so tingnan natin yung condition natin for letter C. So sabi dito ay negative daw tong delta H, and then at the same time positive daw tong si delta S. Okay. Ngayon, ang titingnan ulit natin is hahanap tayo ng way para mag-negative ulit si Gibbs free energy based on the condition for enthalpy and entropy. So, based on this one, positive to, negative na to. So, kung i-imagine nyo student, ano daw dapat yung temperature? So, dapat yung temperature dito ay mataas or mababa? Okay, to answer that question, it doesn't matter. So, dito for letter C, all temp to. Okay, anong ibig sabihin ng all temperature? Regardless kung anong temperature to student, whether mataas na temperature or mababang temperature, magne-negative pa rin si delta G dahil sa condition nga na negative si enthalpy natin and positive to. So, ito, positive times negative, negative, tapos negative, magsasama lang yun, lalaki yung value ng negative sign natin or lalaki yung magnitude ng value natin for your free energy pag ganito yung condition. So at the end of the day, students, free energy is always negative or spontaneous pag ang condition natin ay negative si enthalpy and positive si entropy. So regardless of the temperature, lagi pa ring magne-negative si free energy. Okay? Punta naman tayo dito sa last condition natin, which is si letter D. Sabi dito, negative daw to. So, ano yung pwede nating expect na temperature para makonsider natin or para magawa natin ng paraan para maging negative si free energy? So, as you can see, student, no, negative na tong enthalpy natin dito. Tapos ito, negative din si entropy natin. So, kung minultiply natin tong negative sign dito sa negative dito, magpa-positive to. Okay? Pero meron tayong pwede pa rin gawin para maging negative si delta G. And ano yung gagawin natin na temperature? Ang temperature daw dapat natin is low temp. Bakit low temp? Kasi kung magpa-positive tong value na to or magpa-positive yung value natin dito kasi nga negative yung value or yung sign ni entropy, dapat itong temperature na to ay sobrang baba na para pag minultiply mo siya kay entropy at in-add mo siya kay enthalpy na negative yung sign, hindi niya ma-overpower yung value dito ni enthalpy. In that case, pwede pa rin mag-negative yung sign natin for free energies. Okay? So, for condition letter D, pag negative both si enthalpy and si entropy, no? Dapat yung temperature natin na in-expect is at low temperature. Okay? So students, no, wala tayong example for all these conditions or all these factors because this is actually a supplementary ano lang, no? Supplementary lesson lang or additive lang siya sa lesson natin for the factors affecting the spontaneity of free energy. But anyway, students, this particular formula is very easy to use, no? Kasi tignan nyo naman, yung operation natin dito is multiplication and subtraction lang. So technically, what you're going to remember na lang for this table is that yung mga condition, no? Kung parehas na positive, at what temperature maging negative si delta G, and so on and so forth. Okay, so for condition A, pag parehas positive at high temp, para maging negative si free energy. Sa condition B, pag positive si enthalpy at negative si entropy, no temperature yung makakapagpabago or walang temperature yung makakatulong sa ating formula para mag-negative si free energy. So pag ganito yung condition, free energy is always positive. So no temp. Okay, so for the third condition, kung saan negative si enthalpy and positive si entropy at all temperature, no, regardless of the temperature, whether high or low, always magdi-negative pa rin si free energy. While for condition letter D, pag parehas na negative si entropy and enthalpy, you need to have a low temperature para magkaroon tayo ng value na negative kay free energy. Okay, ganun lang yun, no? Ganun lang kadali yan. Okay? Moving forward, pupunta na tayo dito sa free energy and chemical equilibrium. So, one moment lang. Okay. Students, no? There's a relationship between the standard state and non-standard state of free energy. So, sulat natin yung formula na yun, no? That formula is delta G is equal to the delta G naught. Pangit. Delta G naught. Tapos, that will be positive or plus tuloy. Positive tuloy. Plus RT ln of Q. Okay. So, ito yung relationship between a standard and non-standard free energy. Okay, students, no? I-define muna natin yung mga terminologies dito or yung mga term natin dito sa equation. Pag nakakita kayo ng delta G na walang bilog sa taas, yan yung tinatawag nating non-standard free energy. Okay? Pag walang bilog sa taas or yung tinatawag nating not, this is a non-standard free energy. So, for this statement naman, balitan natin yung kulay. Etong statement etong term naman na to na merong not sa taas nung free energy natin, yan yung tinatawag nating standard. Okay, so this is your standard free energy. Etong R naman na to, student, this is your gas constant which is 8.314 Joule mole Kelvin. Okay, very familiar na dapat kayo at this stage kung ano yung mga values ng gas constant natin. Okay, etong temperature naman na to, this should always be in Kelvin scale. And etong Q naman na to, yan yung tinatawag nating reaction quotient. Okay. Actually, student, may introduce pa tayong isang term. Yan si K. Okay, so introduce ko si K, which is yan naman ang tinatawag nating equilibrium constant. Okay, so equilibrium constant. Okay. Ngayon, student, no, for some of you, siguro hindi kayo nag-STEM or may mga iba naman sa inyo siguro nakapag-STEM naman, pero hindi nyo siguro inabot itong si Q or si K. So, sino nga ba talaga si Q at sino nga ba talaga si K? Okay, so yun yung tanong natin, no? What is Q? And at the same time, what is K? So, actually, student, Q and K are equilibrium constants. No? Para silang equilibrium constants. Pero ano ba yung meaning ng salitang equilibrium? So, madalas kasi kanina, ever since from our last lesson, we've been talking about equilibrium. Pero ano ba yung meaning natin ng equilibrium? Okay, punta tayo dito sa slide natin dito sa baba. No? And let's discuss what equilibrium is all about, no? So students, no, in most of your chemistries, madalas ang nakikita nyo sa isang chemical reaction ay yung tinatawag nating reaction arrow na isa lang yung direction. Yung ganito lang, oh, paturo lang siya lagi doon sa product side, or madalas nakikita natin siya nakaturo sa right side. But in some chemical reaction, student, meron tayong tinatawag nitong equilibrium arrow. So, mapapansin nyo, student, no, itong arrow na to, nakaturo siya both papunta sa product and nakaturo din siya papunta sa reactant. So, ngayon, student, no, ano yung meaning pag ganun yung arrow natin or ganun yung reaction arrow natin, no? Or in chemistry nga, tinatawag natin tong equilibrium arrow. Ngayon, pag ganyan, yung nakikita natin, ang ibig sabihin lang yan is the rate of the forward reaction and the rate of the backward reaction is at equilibrium. Okay, so meaning, nangyayari yung forward reaction spontaneously and nangyayari yung reverse reaction spontaneously. Yun lang ibig sabihin nun. Kasi nga, at equilibrium sila. Or to give it a scientific definition, when we say equilibrium, it is the state of the system where the reaction happens in two directions. One is in the forward reaction, which is yung papunta sa product, and the next one is your reverse reaction, which is yung pabalik sa reactant. Okay? So, hopefully may natutunan kayo doon. So, pag nakita kayo ng double-headed arrow, ang ibig sabihin niyan ay equilibrium. Okay? So, pag sinabi natin equilibrium, yung rate ng forward reaction ay equal lang sa reverse reaction. So, pwedeng mangyari yung papunta dito, pwede rin mangyari yung papunta sa kabila. But anyways, no, as I've mentioned, kaya tayo nagdi-discuss or kaya natin dinidiscuss tong part na to is for you to, or for me to introduce you to Q as your reaction quotient and your K as your equilibrium constant. So, ito kasing dalawang to, gagamitin natin yung student for the relationship between the standard free energy, yung may not or may bilog sa taas, and the non-standard free energy or yung walang bilog sa taas. Okay, so kailangan nating matutunan kung paano natin isusulat itong dalawang to. Okay, but anyway, students, no, actually and Q are actually similar. So, may similarity lang sila. So, later on, ipapakita ko kung ano lang yung parang nagdi-distinguish kay K and kay Q. But actually, no, similar lang din naman sila. So, both of this actually have a numerical value, pero tuturo ko muna sa inyo kung paano ito sinusulat. Okay? So, for equilibrium constant, it is the ratio of the concentration of the product over the reactant raised to their stoichiometric coefficient. Okay? So, paano natin isusulat yon? So, student, ito let's say ito yung example natin ng isang chemical reaction. So, yung mga small letters, sila yung nagre-represent sa stoichiometric coefficient natin, while the capital letters represent our chemicals or kung sino yung mga nagpa-participate sa isang chemical reaction. So, sabi daw natin, for equilibrium constant, it is the ratio of the product over the reactant. So, paano natin sisulat yan? So, ganito lang, no? Ganito lang kasimple. So, K is equal to, so, product, no? Anong product natin? C, tsaka si D. Tapos, yung, ano natin? Yung ating reactant is si A and si B. Okay? Ngayon, sabi natin kanina, ratio ng concentration daw ng product and reactant, pero at the same time, i-raise daw dapat natin sila sa stoichiometric coefficient nila. So, this is raised to C, raised to D, raised to A, and raised to B. O, ganun lang yun. Ganun lang kadali isulat si K. So, for Q naman, same nga lang din sila, pero this should be in the initial stage or before the reaction happens. So, for Q, same lang din, no? Ratio lang din siya ng product over reactant raised to their stoichiometric coefficient, pero at the initial state. So, sulat lang natin ulit, no? C raised to C na maliit, D raised to D na maliit, A raised to A na maliit, and then B raised to B na maliit. Okay. Anyway, sabi nga natin, yung magde-differentiate lang between Q and K is si Q is nangyayari siya at the initial state. So, lalagyan natin ng I. Okay? So, yung I na yan, siya yung magsasabi na ito yung concentration nila before the reaction happens. Okay? So, ganun lang yun. Yan lang yung difference or ito lang yung nagde-differentiate from Q to K. But anyways, parehas lang din naman sila kung paano sila sinusulat. Okay? So, ngayon, practice tayo, no? Practice pa tayo. Practicein natin to. Okay? Practice natin to isulat. Okay. So, one moment lang. Okay. Sulat ulit natin to. So, meron tayo ditong reaction. Okay? Meron tayong chemical reaction. Try natin isulat to. Okay. So, for K, okay, product over reactant. Sulat mo muna yung nasa product. So, yung product natin is si ammonia lang, no? Si NH3 lang. Okay? Okay. Ngayon, sa reactant natin, meron tayong si nitrogen gas. And then, sinong isa? Si hydrogen gas. Okay? Ngayon, i-raise down natin sila sa stoichiometric coefficient nila. So, for ammonia, raised to 2 siya. For nitrogen, raised to 1. And for hydrogen, it should be raised to 3. So, this is 1 and this is 3. Ganun lang yan. Ganun din sa Q. Okay? But, sa Q, dapat nasa initial state siya. So, sulat lang natin, kopyahin lang natin ginawa natin sa K. 2 and 2, 1, and then lastly is si H2, which is 3. But, dapat lahat ng yan ay nasa initial state. Okay? Ganun lang kabilis. So, ganyan magsulat ng Q and K. Ngayon, ano ulit yung purpose ni reaction quotient and ni equilibrium constant? So, yun yung papakita natin down below. So, one moment lang. Okay. As you can see dito sa formula natin, no? Or rather dun sa relationship natin ng standard free energy and non-standard free energy, pag ang pinapahanap sa atin is yung standard free energy or kung saan may not, etong bilog sa taas, si K ang gagamitin natin or si equilibrium constant. Pero pag non-standard yung free energy na pinapahanap sa atin or etong G na walang not sa taas, si Q yung gagamitin natin or si reaction quotient. So, nandito na yung formula ha. For standard free energy, ito yung gagamitin natin. For non-standard free energy, ito yung formula na gagamitin natin. Okay, with that said, let's solve for some of the given problems na meron tayo dito down below. Okay? So, solve lang natin yan. So, sabi dito, calculate the equilibrium constant for the following reaction at 25 degrees Celsius and determine their spontaneity. So, ang pinapahanap sa atin dito ay si K. So, dahil si K yung pinapahanap sa atin dito, ang gagamitin nating formula is yung for standard free energy, which is yung product minus reactant. Okay. So, paano yung formula nun? Anong formula nun? Yung delta G of the reaction, tapos yung summation ng moles of the product multiplied by their standard free energy of the product, tapos subtracted by N M to, or yung moles ng reactant multiplied by their standard free energy of the reactant. So, ganun lang yun. So, automatically, lahat ng values ulit na to, students, makikita lang natin sa thermodynamic data. So, tignan natin, no? Si H2O liquid, alam natin yung value niya, nakita natin kanina. So, hanapin natin. Okay. So, for H2O liquid, that is negative 237.2. Sulat natin na for H2O, wag ganyan. For H2O liquid, no, uh, free energy or standard free energy of H2O, that is negative 237.2. Anong unit? Kilojoule per mole. Okay. Ngayon, tingnan natin yung standard free energy ni oxygen gas and ni hydrogen gas. So yun yung hahanapin natin. So, based on this thermodynamic data, alam natin si oxygen gas kanina, nakita na natin 0 yun eh. So, kung ayaw nyo maniwala, hanapin ulit natin si oxygen gas. So, alam ko si oxygen gas 0 siya. Ito siya, oxygen gas 0. Okay, ngayon hanapin na lang natin si hydrogen gas. So, si hydrogen gas ay, nasa taas yun? Sa taas ata. Sa taas ba? Wala siya doon. Eto, si hydrogen gas ay 0 din. So, parehas silang 0. So, 0 kilojoule per mole. Eto, 0 kilojoule per mole. Okay, so technically, yung product natin na statement ay parehas na 0 na. So, no need na. No need na nating isolve yung part na yan. Or, kung ilalagay natin siya sa value natin or sa formula natin rather, ang mangyayari lang dito is 0 na yung product natin minus doon na lang tayo sa reactant. So that is 2 moles ng water multiplied by negative 237.2 kilojoule per mole. So technically, multiply mo lang to ng 2 tas may negative sign, magpa-positive to. So ang sagot natin dito ay positive 474.4 kilojoule. So because this is a positive value, then technically we can conclude that for this particular chemical reaction, this is an example of a, palitan natin yung kulay para ma-distinguish natin. This is an example of a non-spontaneous process. Kasi based on the question din, tinatanong tayo, determine the spontaneity. So non-spontaneous yung process. So, ibig sabihin, kung titignan nyo lang din naman tong example natin dito, student, no, never ka naman nakakita ng tubig tas nagiging hydrogen gas at oxygen gas lang din naman siya out of nowhere. So, technically, that's impossible. Let's say, for example, nag-iwan ka ng tubig sa lamesa. Hindi naman siya out of nowhere nagiging hydrogen gas. Hindi rin naman siya out of nowhere nagiging oxygen gas. So, technically, this particular chemical reaction is non-spontaneous or non-occurring. No? So, bakit siya non-spontaneous? Kasi yung value natin for the standard free energy ay positive. And again, bakit yung standard free energy yung ginamit natin? Kasi based on the question, ang pinapahanap sa atin is yung equilibrium constant or CK. So, now na nasabi ko na si K yung hinahanap natin, no? Let us now solve for K. Okay, so hanapin na natin si K. Okay, so nahanap na natin kasi yung spontaneity ng process or ng reaction natin. Ngayon, si equilibrium constant naman na. So, palit lang tayo ng color ng pen. Okay, so 4K na to. 4K. So, based on the formula above, ano to gagamitin natin? Standard free energy is equal to negative RT ln of K. So, yun yung formula natin, no? Standard free energy is equal to negative RT ln of K. So, technically, si K yung hinahanap natin. So, i-isolate natin si K. So, ang mangyayari dito is standard free energy over RT is equal to ln of K or the natural logarithm of K. Ngayon, students, no, paano natin ma-isolate si K? No? Paano natin ma-isolate si K kung meron ditong natural logarithm? So, in that case, no, balikan lang, mag-discuss lang tayo ng quick, or rather, let's have a quick review kung paano natin i-isolate si K sa mga ganitong situation. So, palitan lang natin yung kulay. So, dito tayo review. Okay, so imagine nyo, student, no, you're trying to isolate for K, pero naka-logarithm siya. So, ang gagawin natin daw dito is i-isolate natin si K. Okay, pero naka-logarithm muna. So, in this case, pag gusto natin daw i-isolate si K, we have to do the antilog or the antilog. So, in that case, i-erase mo yung nanditong equation or yung nanditong part ng equation and itong part ng equation by 10. Kasi yun yung antilog. So, that is 10 raised to x is equal to 10 raised to logarithm of k. So, dahil 10 and ito ay same lang, magka-cancel daw to. So, ang magiging final na relationship nito pag nag-apply tayo ng anti-log is magiging 10x is equal to k. Okay. Ngayon, students, pwede rin natin yan gawin sa natural logarithm or yung tinatawag nating ln. So, let's say meron kang x ulit, tapos meron kang ln or natural logarithm of k. In this case, student, hindi natin gagamitin yung antilog. Pero there is a similar way para ma-isolate natin si k, no, pag naka-natural logarithm using this concept about logarithm and antilog. And that is ang gagawin lang natin dito is gagamitin natin yung Euler's number, no? So, yung Euler's number is yung e raised to x. Re-raise lang natin using the Euler's number. Ito yung Euler's number, yung e. So, nandyan yan sa calculator nyo. So, hopefully marunong kayong gumamit ng calculator nyo para mapalabas to. But anyways, that will be e raised to ln over k or times k. So, in this case, pares lang naman si e or si Euler's number kay natural logarithm. So, cancel yon. So, ang final natin na statement here is ganito. So, ngayon, ito i-apply natin dito. So, in applying that, ang magiging equation na natin ay e raised to delta g. Okay, may nakalimutan ako dito. May negative pala tong RT. So, dapat may negative to. Okay? So, the standard free energy RT, naka-raise na siya sa Euler's number. Okay? And then, na-isolate na natin si K. So, technically, pwede na natin ma-solve si K. So, in that case, student, plug in lang natin lahat ng values natin. Okay? So, wait lang. Mamaya ako na isusulat si K. Sulat ko muna yung formula. Okay? So, in this case, gagamitin lang natin yung calculate nating standard free energy which is 474.4 kilojoule. Ano yung unit natin sa taas? Kilojoule. Okay. For the gas constant, that is 8.314, no? Pero yung unit kasi natin doon is naka-joule. So, pwede nating i-convert tong 474.4 kilojoule into joule by multiplying this 1,000 or pwede nating i-divide ng 1,000 si gas constant. So, i-divide na lang natin ng 1,000 si gas constant. So, you can actually write 8.314 times 10 raised to negative 3 na lang. Meaning, dinivide mo ng 1,000. Tas ang unit na niya is kilojoule mole Kelvin. Okay. Ngayon, si temperature ay 25 degrees Celsius or pag ginawa mong Kelvin, 298.15 Kelvin. Okay. So, students, bakit tayo nag-divide ng 1,000 dito kay gas constant? It's because, student, yung 8.314 kasi na gas constant, naka-joule mole Kelvin yon. Kung ipipilit natin to dito, hindi natin makakancel yung unit. So, it's either i-convert mo to, gagawin mong kilojoule, or yung kilojoule dito, i-convert mo into joule. Pero mas maganda yung gas constant na lang yung i-convert natin kasi para hindi lumaki yung value sa taas. But anyways, parehas lang din naman yun. Whatever you prefer, no? Kayong bahala doon. Okay? Anyway, student, so looking at this one, parang katapat na lang nila kasi si E. Pero naka-raise yan, ha? E tapos raise to this. In this case, student, magka-cancel si kilojoule, magka-cancel si Kelvin, tapos magka-cancel na rin si mole. Ngayon, students, you might be wondering, bakit na-cancel si mole? Wala namang mole. Okay. Explain ko ha. In some cases kasi students, yung value talaga ng standard free energy, it could either be in kilojoules or in kilojoules per mole. So, tayo kasi nakalculate natin kilojoules, pero may mga ibang may mga ibang situation na yung unit is kilojoules per mole pa rin. So in that case, assume na lang natin na kilojoules per mole na to, kaya makakancel na lang din natin si mole dito sa statement na or dito sa unit natin sa baba for gas constant. So with that said, no, anong value ng K natin? So K will be equal to 7.66 times 10 raised to negative 84. So, ito yung equilibrium constant natin. Ngayon, iintindihan natin kung bakit ganito rin yung nakuha natin. No? Bakit kaya ganito yung nakuha natin? Okay, so balikan natin yung table natin sa taas. Okay. So, ito yung table natin sa taas. Sabi dito, student, ito yung table natin, no? Sa taas. Ngayon, iintindihan natin kung bakit ganun yung nakuha nating value. So, sabi natin kanina, or based dun sa problem natin nakuha, positive yung delta G natin. Or yung standard free energy natin, positive. So, pag positive daw siya, we expect that the equilibrium constant should be less than 0 or less than 1. So, technically, pag ganun yung nangyari, reactants are favored over the products at equilibrium. Meaning, mas gusto ng reactants na magstay sila kesa mag-produce sila ng product. Kasi nga, non-spontaneous yung process. So, pag positive yung delta G mo or non-spontaneous yung reaction mo, you expect the equilibrium constant should be less than 1, which is, kung titignan mo nga naman yung na-calculate nating equilibrium constant, it is raised to negative 84, which is very far or very small number, no? So, sobrang layo niyan sa 1. So, technically, tama yung sagot natin. Kasi positive yung delta G natin, dapat yung K na makakalculate mo is less than negative 1. So, K is less than 1 because the standard free energy is positive. Okay, so ito yung statement natin diyan. Okay? In that case, students, kayo naman gagawa ulit nito. Okay? So, susulat na lang ulit ni sir kung ano yung mga sagot dito. But anyways, practice this. Ito kumbaga yung practice problem nyo. So, same lang yung gagawin dito sa ginawa sa task ni sir, no? So, for the delta G of the reaction or the standard free energy of the reaction, yung sagot natin dito is negative 328, this should be negative 326.8 kilojoules. And then your equilibrium constant is equivalent to 1.80 times 10 raised to 57. Okay. Intindihin natin yung mga nakalculate na sagot dito ha. Ito yung target yung dalawa na answer. Okay. So for the delta G of the reaction or the standard free energy of the reaction, the value is negative. So technically, this particular chemical reaction is a spontaneous process. So spontaneous yung process na to kasi nga negative yung value natin for the free energy. Ngayon, balikan natin yung table ulit sa taas. So, dito, sinasabi sa table na pag negative yung value mo for delta G, dapat daw yung equilibrium constant mo should be greater than 1. So, dapat mas malaki yung K mo sa 1. So, tignan natin yung nakalculate nating K dun sa example sa baba kung mas malaki nga siya sa 1. So, based on this calculation na ginawa ko on my end, the equilibrium constant for the standard free energy of the reaction for this particular chemical reaction ay 1.80 times 10 raised to 57. So, this is a very large number, no? So, 1.80 tapos 57 pa or 55 na zeros pa. O, diba? Imagine that, no? Sobrang laki ng equilibrium constant na to. And in this case, medyo magiging confident ka sa na-solve mo. Kasi yun yung condition na sinet sa taas eh. Magtaka ka dyan kung spontaneous yung process mo, pero yung equilibrium constant mo less than 1. Doon ka magtataka. Ha? Doon ka magtaka. Okay? Pero pag spontaneous yung process mo, tas greater than 1 yung nakuha mong equilibrium constant, then maybe your calculation is correct, no? The same way dito sa ginawa natin sa taas, which is ang nangyari dito is non-spontaneous yung process natin, or positive C delta G natin, or the standard free energy of the reaction natin. So we assume, or we expect rather, that the equilibrium constant for this particular example should be less than 1 kasi nga non-spontaneous yung process natin. Okay? So for this particular example, K should be greater than 1 because delta G of the reaction is negative. Ito yung implication ng dalawang nakuha yung dalawang nakuha kong value. So, try solving this one. Okay? For your reference, gawin nyo lang yung ginawa natin dito sa taas. Makukuha nyo yung sagot. Okay? Okay. Anyways, sobra lang tong slide na to. Huwag na nating discuss. Sobra lang tong slide na to. So, hindi kakailanganin. Okay. In this case, anong pang pwede natin gawin dito? Okay. So, one moment lang ha. Okay, so gawin na natin. Okay, so calculate the standard free energy for the following reaction at room temperature. Okay, so this is a very straightforward application of our discussion. Bakit siya straightforward? So as you can see, given na sa atin yung equilibrium constant, so we can actually use the formula. Standard free energy is equal to negative RT ln of K. Very straightforward na. So, paano natin nilalagay yung value? So, that is 8.314. Gawin na lang natin, times 10 raised to negative 3 na lang to. Kasi madalas yung value, yung unit natin for free energy is kilojoules per mole. So, that is kilojoules Kelvin per mole. Times temperature, at room temperature daw, so that is 25. So that is 298.15 Kelvin. So at room temperature, that is 25 degrees Celsius. Convert mo into Kelvin, ito yung sagot. Okay? Times ln, lagay mo lang tong value na to. 1.6 times 10 raised to negative 10. Okay, from there, ang sagot natin ay 55.91 kilojoules per mole. Okay, so cancel lang dito yung Kelvin. Ito na yung final answer natin. So, moving forward, sagutan na rin natin tong pangalawa. Paano ito sasagutan? Okay. So, ang gagawin lang natin dito is, apply lang din natin ginawa natin sa kabila, no? Standard free energy is equal to negative RT ln of K. So, itong KSP siya, itong C, equilibrium constant. So, you have your 8.314, convert mo na into kilojoules. So, times 10 raised to negative 3. That is kilojoules mole per Kelvin or Kelvin per mole. Times, anong temperature natin? Room daw. So, 298.15 pa rin. Kelvin times ln ng KSP natin. So, that is 1.7 times 10 raised to negative 6. So, ang sagot dito ay negative tuloy. Ang sagot natin dyan ay positive pa rin. So, this is positive 32.93 kilojoule per mole. Okay, box lang natin para alam niyo yung final answer. Okay. So anyways, pwede rin namang joule per mole yung unit mo dito, but sobrang laki kasi ng value na yun eh. So magiging parang 32,000 or 300,000 something yun. So kaya natin kino-convert na dito pa lang yung gas constant natin into kilojoules kesa gamitin natin siya as joules. But anyways, regardless kung joule per mole yan or kilojoules per mole yan, tatanggapin ko pa rin naman yung sagot kasi nagkatalo lang naman siya sa unit. Okay? Moving forward, so, sagutan natin to. Okay? So, sagutan lang natin to. Okay, so dalawa yung pinapahanap dito sa atin, no? So consider the reaction, calcium sulfate will turn into calcium and sulfate. Okay, so calculate the standard free energy at 25 degrees Celsius. What should be the concentration of calcium and sulfate? Okay, so B, so that delta G is equal to negative 1 kilojoule. Take calcium 2 plus is equal to sulfate. Okay, so meaning, pinapahanap sa atin dito yung concentration ni calcium and ni sulfate. But anyways, focus muna tayo sa letter A. So, calculate the delta G or the standard free energy. So, ganun lang din, no? Product minus reactant. Tignan mo lang yung values nila. Nasa ano naman yun eh. Nasa thermodynamic data. So, anyways, ang value natin for calcium ay negative 553. Tapos, for sulfate, that is negative 741.99. Negative 741.99. Tapos, si calcium sulfate ay negative 1,320. So, negative 1,320.3. Lahat yan naka-kilojoules per moles. 0.3. Okay, so plug-in lang natin product minus reactant. Okay? So, in this case, hinahanap natin si standard free energy, ha? So, product, calcium muna. Si calcium ay may 1 mole multiplied by negative 553 kilojoules per mole plus sulfate, ilang moles? 1 lang din. Multiplied by negative 741.99 kilojoules. Pangit ang sulat. Kilojoules per mole. And then lastly, isubtract mo siya sa value ni calcium sulfate, which is 1 mole lang din naman, multiplied by negative 1,320.3 kilojoule per mole. Okay. Moving forward, ang sagot natin makakalculate dyan ay positive 25.31 kilojoule per mole, or kilojoule na lang kasi cancel si mole. Okay. So, ganun lang mag-calculate ng letter A, no? So, gamitin mo lang yung product minus reactant na formula natin for standard free energy. Hindi mo naman pwede magamit yung negative RT ln of K kasi wala nang binigay na equilibrium constant. So, anyways, ito yung sagot natin for letter A. So, ngayon punta tayo sa letter B. Okay, sagutan natin yung letter B. So, for letter B, students, no? What should be the concentration of yung calcium natin and sulfate natin? Okay, as you can see, binigyan tayo ng non-standard free energy dito. Okay? So, dahil binigyan tayo ng non-standard free energy dito, automatically, we expect to use the formula delta G, or the non-standard free energy, is equal to the standard free energy plus RT ln of Q. Okay? So, ito yung formula natin na gagamitin. Okay? In this case, isulat lang natin si Q. Okay? Katulad ng practice natin last time. Okay? Sulat lang natin si Q. So, Q is the ratio of product over reactant, no? So, in this particular chemical equation, students, no, ang ginagamit lang natin or yung sinusulat lang natin for the equilibrium constant and the reaction quotient is yung mga naka-aqueous and naka-gas lang. So, hindi natin pwedeng gamitin or hindi natin sinusulat si solid and liquid, pero pwede natin gamitin si gas and si aqueous. Okay? Aqueous. Anong meaning ulit ng aqueous or AQ? Meaning natutunaw siya sa tubig, or yon, kaya siyang matunaw sa tubig. Yung meaning ng aqueous natin. Okay? Moving forward. So, dito kung makikita nyo, ang product natin ay si calcium lang, 2+, and then si sulfate. Tama? Tapos kung mapapansin nyo, wala naman sila, isa lang yung mole nila, so automatically raised to 1 na lang yan. Pag wala naman nakalagay dyan na number, we assume that to be 1. Okay? Anyways, sabi nga natin, ang ginagamit lang natin for the reaction quotient and the equilibrium constants or gas and aqueous, so hindi natin isusulat si calcium sulfate kasi nga, solid siya. Ayan o, solid siya. So because of that, ito na yung final natin na equation. Pero based on the problem, ang hinahanap daw natin is yung concentration ni calcium and ni sulfate. So let this and this be x, no? So gawin natin siyang x. So palitan natin na lang yung kulay para ma-identify nyo kung anong ginagawa natin dito. So as let calcium and sulfate be x kasi nga sila yung hinahanap natin. Okay? So in that case, simplify pa natin yung formula natin, no? Nagde-derive tayo ng equation dito. So delta G is equal to the standard free energy plus RT ln of x squared. Kasi x times x, that is x squared, no? Lagyan lang natin ng parenthesis. Okay? So, transpose natin yung G na to sa kabila, no? So, magiging delta G or the non-standard free energy subtracted by the standard free energy. So, non-standard free energy minus standard free energy is equal to RT ln of x squared. Okay? So, from there, anong pwede natin gawin? I-divide natin both sides by the gas constant and temperature. So, ang next natin na makikitang equation ay delta G minus the standard free energy over RT is equal to the natural logarithm of x squared. Okay? From here, anong pwede natin gawin? Gawin din natin yung Euler's number ulit, yung tinuro ko kanina. Tapos at the same time, tanggalin natin yung x dito. Kasi ina-assume lang din naman, yung exponent na to dito. Kasi ina-assume naman daw natin na calcium and sulfate are equal. So, Euler's number, E delta G minus delta G naught over RT is equal to x squared. Tapos tanggalin natin tong dito, no? Itong exponent na to. So, pag tinanggal mo to, makakancel lang yan and then magkakaroon lang to ng square root. Okay. So, eto na, may square root na to. So, ito yung final nating equation para mahanap natin yung concentration ni calcium and ni sulfate. Okay? So, let's just plug in the values, Okay? So, plugging in the values, ano yung standard free energy na, or non-standard muna? Negative 1 kilojoule. 1 kilojoule, Okay, after that, ano yung next natin? Kilojoule to. So, kilojoule to. And then, subtracted by the standard free energy. Ano yung na-calculate natin sa taas? 25.31. So, yung gagamitin lang natin. So, 25.31 kilojoule lang din naman siya. Tapos, gas constant. Again, student, naka-kilojoule na yung mga values natin sa taas. So, dapat yung gas constant natin naka-kilojoule na din. So, times 10 raised to negative 3 mo lang. Parang minultiply mo na rin siya, or rather, dinivide mo na siya ng 1,000. Okay? So, ang unit na nito ay kilojoule, mole, Kelvin. And then, yung temperature natin is at 25 degrees Celsius. So, convert mo yun into Kelvin to 98.15 Kelvin. So, from here, students, no, papakita ko lang yung cancellation ng units. Maka-cancel si kilojoules, tapos si Kelvin. Tapos sabi ko nga students, no, in some scenarios, yung unit natin for the standard free energy and the non-standard free energy is naka-kilojoules per mole, no? So, pwede na lang din natin i-assume na maka-cancel na lang din si moles, okay? Okay, simplify na natin to. Ang magiging sagot natin dito is, for the concentration, ang sagot natin ay 4.96 times 10 raised to negative 3. Okay, so yan na yung final answer natin, no? 4.96 times 10 raised to negative 3. Or kung gagawin natin or ipa-plugin natin to dito, magiging ganito na lang siya, no? Calcium 2 plus, ang sagot dyan is 4.96 times 10 raised to negative 3. So, dahil sabi niya concentration, dapat yung unit niya is in concentration unit din. So, lagyan na lang natin ng molarity. Okay? So, siguro yung iba dyan, ano yung molarity? Paano naging concentration unit yon? But anyways, no? Assume mo na lang na molarity yan kasi nga concentration units yan. But anyways, for sulfate naman, same lang din, 4.96 times 10 raised to negative 3 molarity. Okay, so ang sagot mo ay ito or ito. Okay? So, ganun lang kina-calculate yung letter B. So, technically, no, as you can see, we're already at the end of our lesson for today. So, students, so hopefully may natutunan kayo. Again, meron tayong mga questions dito kanina na hindi na natin sinagutan kasi I expect you to answer it by your own na. So, in that scenario kasi, gusto ko na pa-practice nyo rin mag-solve. Kasi ang hirap na parang, ang hirap na parang lahat is spoon feeding tapos wala kayong practice, 'di ba? Pag wala kasi kayong practice in terms of solving, kahit na basahin nyo or memorize nyo lahat ng konsepto about chemistry, kung wala kang practice sa pagsusolve, you really can't answer problems, no? Or you really can't answer problem-solving questions in chemistry. Kasi it requires, sa chemistry kasi na subject natin, it requires you to study the lesson but also apply the lesson to the different problems, no? Okay, so hopefully everyone will practice in solving. So, binigyan ko kayo ng mga solve dito. At the same time, binigay ko na rin yung sagot para you can solve it on your own. So, ito yung isa na binigay ko sa inyo. And meron pa ako isang binigay kanina. I think nasa taas siya. Ito. So, meron akong binigay sa inyo dalawa. So, hopefully you can practice. Okay? So, with that said, no, kung babalikan natin yung taas, tapos na natin yung chapter 3 natin. So, natakal na natin lahat ng topics dito sa chapter outline natin. And with that said, for chapter 3, which is entropy and free energy, tapos na rin natin yung lecture natin. So, hopefully may natutunan and hopefully na-appreciate yung lesson natin. Again, sabi ko nga, hindi nyo naman kailangan maging paborito yung chemistry as a subject. What you can do na lang para ma-survive yung chemistry is to appreciate it, no? As engineering students, yung mga konsepto natin for thermodynamics, pwede nyo siyang gamitin in a day-to-day basis. Especially for entropy and of course, spontaneity, no? You can actually understand processes na sometimes may mga process tayong hindi talaga or wala siyang reverse reaction, not unless magkakaroon ng intervention, 'di ba? And for free energy naman, yun nga, another type of energy na pwede nating gamitin para mas maintindihan yung mga reaction na nangyayari sa paligid natin. Okay? So, summarize lang natin ulit. For the free energy, ang natin dito, ang basihan natin para malamang spontaneous yung process is dapat negative siya. For entropy naman, ang basihan natin dito is yung delta S universe pero dapat positive yung value para masabi nating spontaneous. Okay, so with that said, I'll end our lecture na po. Maraming salamat sa panunood.